Hello and welcome to College Algebra 1.6, other types of equations. Today we're going to focus on radicals, radicals with square roots, rationals, we're back to fractions again, and absolute value, which we haven't really talked about a ton here. So let's get into it. First, radical equations. You want to isolate the radical, whatever has the square root or, sorry, cube root or anything, you want to get by itself. So here we have it completely by itself. So to undo the square root, we're going to square it, which means we also have to square the other side. Square root of x plus 2 squared is just x plus 2. And 3 squared would, of course, be 9. From there, we can minus 2, we get x equals 7. Now, whenever we're doing square roots, it's important we test our solutions because some wonky things can happen. So let's test our solution by plugging in 7 in for x. So let's test square root of 7 plus 2. Does it equal 3? Well, 7 plus 2 would be 9. The square root of 9 would be 3, so this works out. So x equals 7. Over here, we want to get the radical by itself, so we're going to add x to both sides. And so we get the square root of 2x plus 7 equals x plus 2, just standard form, so just rearranging the order. And we're going to square both sides. So we get 2x plus 7 over here. But here I get x plus 2 times x plus 2, and I had to FOIL that out, or distribution property. So we would get x squared plus 4x plus 4. Because I have x squared and some regular x terms, I know I'm probably going to solve by factoring, which means I want to get one side equal to 0. So we get 0 equals x squared, 4x minus 2x is 2x, 4 minus 7 is negative 3. We can factor this. What multiplies to negative 3 adds to positive 2. That sounds like plus 3 and minus 1. So my potential solutions using the zero product property are going to be negative 3 and positive 1. Again, setting both those parentheses equal to 0. So let's test negative 3 into our original equation. 2 times negative 3 plus 7 minus negative 3, does it equal 2? Well, 2 times negative 3 is negative 6, plus 7 is the square root of 1, which gives me 1. Subtracting a negative 3 turns into 1 plus 3, which would be 4. Does 4 equal 2? No. So negative 3 is actually an extraneous solution. What does that mean? Well, the first 5 letters in extraneous are extra. It just means it's a solution that doesn't actually work out. It's extra in creative. So let's test positive 1. 2 times positive 1 plus 7 minus 1. Does it equal 2? 2 times 1 is 2, plus 7 is 9, square root of 9 is 3, 3 minus 1 is 2. Does 2 equal 2? Of course, so 1 is an actual solution. Okay. Back to rationals. Big thing, common denominator, so I can get rid of everything else. And remember, when I talk about common denominators, I'm talking about factors, aka things that multiply. So, well, first we can put this 1 over 1, and I can recognize that this first fraction has an x, but it doesn't have the factor x minus 2. So I'm going to multiply that by x minus 2 over x minus 2. This second fraction has x minus 2, but it doesn't have x alone as a factor. So I'm going to multiply that one by x over x. And this third one doesn't have either of them, so it needs the x over x as well as x plus 2 over x plus 2. So first we would distribute the 2, so 2x minus 4 over x minus 2 equals 3 times x, so just 3x over x minus 2. And this one's actually kind of interesting. I get 1 times x, which is going to give me negative 1x. And then I still have this x plus 2. And I can distribute negative 1x to both of those things. So, because I'm distributing the negative already, I can change this to a plus sign. And we would get negative x squared minus 2x over x plus 2. What you could have also done here in this step is just distributed the positive one. So you would get x squared plus 2x, but then you'd be subtracting this entire fraction and you'd have to distribute the negative anyway. So either way, it all works out. Now that we have the same denominator everywhere, we can multiply the entire thing by x minus 2. This should have been x minus 2 from the beginning. I don't know why I had x plus 2. Which means that this should be a plus. Goodness gracious. I apologize if I caused some confusion there. This x minus 2 cancels out the denominators everywhere. So we get 2x minus 4 equals 3x minus x squared plus 2x. I have an x squared term and some regular x terms. So I know I'm probably going to solve by factoring, so I'm going to get them all to one side. The easiest way is going to be subtract 2x and add 4. Well, combining terms, we get 0 equals negative x squared. 3x plus 2x minus 2x is positive 3x, and then the plus 4. Now, when I factor, I typically want my first term to be positive, so I would divide everything by negative 1 here, including the other side as well. The nice thing is 0 divided by negative 1 is still 0. So x squared minus 3x minus 4. What multiplies to negative 4 adds to negative 3. That'd be x minus 4 and x plus 1. So my potential solutions would be 4 and negative 1, and I would test them into my original. So plugging those in, we would get 2 over 4, which is 1/2, and 3 over 4 minus 2 minus 1 on the outside, which is also 1/2. So we see that 4 works. And then I would do the same thing by plugging in negative 1. We get 2 over negative 1, which is negative 2, and 3 over negative 1 minus 2 minus 1, which is also negative 2. So both of those solutions work out. Now, absolute value equations. Absolute value equations, you want to isolate the absolute value, and what you do is it's equal the original, and you do a second equation with you negate one side. It doesn't actually matter which side you negate. I know I put negate the left side, but it doesn't actually matter. So for example, I could do 3x minus 7 equals 4, and 3x minus 7 equals negative 4. The reason it doesn't technically matter is, for a second, let's assume I negated the left-hand side. So that would be negative times 3x minus 7 equals 4. And I distributed this negative, so negative 3x plus 7 equals 4. Or I could divide the entire thing by negative, and I end up with the exact same expression we were just talking about. So as long as you negate only one side, you're fine. And the other nice thing is, while you're solving both equations, the algebra, the steps remain the same. So for example, for both purple and black, I'm going to add 7 to start. So we get 3x equals 11, and 3x equals 3. And then the next step, I would divide both sides by 3. So we get x equals 11 thirds, and x equals 1. And just like with square roots and with rationals, you should also check these as potential solutions. So let's check these as solutions. We get 3 times 11 thirds minus 7 in the absolute value. Does it equal 4? Well, 3 times 11 thirds, the 3's actually simplify out. You end up with 11. 11 minus 7 gives us the absolute value of 4. Does 4 equal 4? Yes, so 11 thirds works. Now let's plug in 1. 3 times 1 minus 7. Does it equal 4? 3 minus 1 would be 3. 3 minus 7 is the absolute value of negative 4. And then recall that absolute value just means distance from 0. Functionally speaking, distances can't be negative, so this becomes a positive value. Does 4 equal 4? That is true, so x equals 1 also works. All right. Here we get the same idea. So I'm going to get x squared minus 1 equals 10, and x squared minus 1 equals negative 10. Well, the first step for both of these is I'm going to add 1. So we get x squared equals 11, and x squared equals negative 9. From here, square root, square root, square root, square root. We square rooted, so we get positive and negative square root of 11. And we square rooted here, so we would get plus and minus the square root of negative 9, which we can do as square root 9 and square root negative 1, or plus and minus 3i. Now, in this situation, we have 4 answers to test, but the imaginaries we don't really have to worry about here in this case, so those I'm not going to have to test. So here I'm going to get positive and negative root 11 to test. So let's start with negative square root of 11. So if I do negative square root of 11 squared in for x, so x squared minus 1, and does it equal 10? Well, what's negative square root of 11 times negative square root of 11? Well, that sounds kind of silly, but let's think about it. Negative times a negative means this has to be a positive value. And anytime I have square roots, I can multiply the insides. So 11 times 11 gives me positive square root of 121, which is 11. So this whole thing as a concept is just 11. So 11 minus 1 gives me 10. And the absolute value of 10 is 10. So the nice thing is, negative square root of 11 works. Well, following that exact same logic, positive square root of 11 would also work because the steps would be the same. I would end up with positive 11 there, minus 1. So both of those solutions do work. That's all I got for you. Thank you for listening, and I hope you have a wonderful day.